thank the Washington State Department of Agriculture for helping us with this project. I'd also like to thank Jake and Jenny DeRuiter for jumping in here with us to do this pilot. And in the end, I think it's in the benefit of everyone that we try new technologies and try to find things that are working. I'm hoping that that's what we're going to find out by the time we're all completed here. So a couple of housekeeping items. If you have any questions, feel free to enter on the section that says question on the side of your screen there. Down lower, you'll see a little arrow that says questions. If we haven't answered your question in the course of the call, we'll answer those questions at the end. Also, we'll be emailing a copy of this presentation to everyone who was on the call. We're also recording this call so that there will be a copy of it online available for a later time should someone wish to listen then. So today, this is Russ Davis with Organics, of course, based in Walla Walla, Washington, which is where we are. I have with me today Matthias Sjogren, the CEO of BioFiltro, and Maya Healy, who's with BioFiltro as the regional manager up here from California. So just a little backstory on how we ended up here. Since about 2005, we've been trying to find a possible answer to address dairy water, how to make it something that we could manage in such a way so that we could take the benefits from the water and turn it into something we can use, basically give the dairyman a tool. And we've looked at, as you all know, we've looked at a lot of opportunities in water treatment, and there's not really been a very good answer in something that we can use that is very functional and cost effective. So the purpose of this event, and specifically the BioFiltro pilot, was to do a test to try to find something that would work in removing nitrogen, at least reducing nitrogen, functionally, practically, without a bunch of technology that's hard or difficult to manage, that would run year-round and would address some of the requirements for dairies, and hopefully in the end of it come up with a product or products that can be utilized. So probably the number one question here in water treatment are the fine solids that come in, for example, after a centrifuge or prior to the lagoon. BioFiltro system is a water treatment system. It's not a solids treatment system. So this has been an ongoing question about what can we do with these fine solids that are suspended in the water. And truthfully, there is no great answer for those solids. So there are possibilities, including things like using polymer or using a DAF and things of that nature. And those things all work, but they're not the most cost effective either. So there's not really a good silver bullet here. But I can say that the BioFiltro is doing its job as requested. It's turned out to be, I think, a pretty good water treatment system for the application. So with that, I'm going to turn this presentation over to Mayan, and she'll take you through BioFiltro first. We'll talk about the company BioFiltro, then we'll talk about the system at the DeRuiter Brothers Dairy. We'll have some Q&A. I mean, I think we'll cover a bunch of ground here today. By the end, you should have a much better understanding what we're trying to do here. So with that, I'm going to turn it over to Maya Healy.
Thanks, Russ, and thanks everyone for attending today. Like he mentioned, I'm just going to briefly overview the BioFiltro technology so you can understand the background of the technology that's being applied here in Washington. So very quickly, what is BioFiltro as a company? What do? We provide patented wastewater filtration systems, which can remove up to 99% of contaminants in a 4-hour process. And so what do we do for dairies specifically? Obviously, many dairies out there, you're running the risk of being out of compliance with your permits. So by removing nutrients from your lagoon water, we're obviously enabling you to comply with your discharge requirements. And at the same point, for the ones who are doing land application with their discharge, we're reducing the pounds per acre per day and acreage needed for land application by cleaning up your water. And also, many of you are dealing with high manure disposal costs. So since we are also a cost-effective solution, we're able to lower your operational costs. And then also the system does not generate any sludge. So you're avoiding having to deal with any lagoon slurry management or draining your lagoons, dredging your lagoons, etc. And also odors. Since our treatment process is a 4-hour process, we're able to clean your water very quickly and effectively so that you're avoiding stagnant water, which is what your lagoons are, of course, doing, and that is what causes the odors. So how do we do that? I don't know how many of you have heard about our technology beforehand, but we're combining the power of worms and microbacteria in order to quickly digest the contaminants. So what exactly is the Beta system, which is our patented system that we are installing? Is a percolating biofilter. It provides physical and biological filtration via intermittent irrigation. That is to say, we take your waste, we build this essentially above ground concrete tank or concrete pool. It's open surface, and we apply the wastewater across the surface system using an irrigation system. And so if you were to side cut our system, this is what it looks like on the inside. So our system as a standalone secondary filtration system is completely natural. There are no chemicals, just in this process what's happening here. So as you can see from the side cut, the system stands about 5 feet tall, and from top to bottom you have a layer of wood shavings, then you have a layer of rocks, and you have drainage basins, which are essentially plastic pallets. All they are doing is maintaining an air chamber at the base of the system. And of course, the system is completely sealed, so that's why you have the concrete floor. And it naturally drains out through the base or through an exit pipe below. The white pipes that you are seeing are passive aeration pipes, so they are connected down to the air chamber below, just providing passive circulation of air. And you can see the irrigation system above as well in its active status. And then what BioFiltro does, our know-how and our knowledge is that we have a patented process for the method and system of inoculating bacteria in contaminated water using worm castings. So essentially when we start up a system, what we do is we inoculate the system with worms and microbes, bacteria, and worm castings, which are preconditioned. So we serve various industries. Of course, in the dairy industry, we would introduce a specific mix of worms and bacteria that target the contaminants commonly found in dairy wastewater. So how does the Beta system work? This is an ideal, or an example process, flow process. We always have some sort of primary solid separation. We always have some sort of primary solid separation up front. In this case, in this design, a rotary screen is being presented. Then we have a small accumulation tank as well. And sometimes we can just use the lagoons in the case of the dairy. And all that is doing is providing a small accumulation time for the irrigation system to build up enough volume and then be able to irrigate. So then the water naturally percolates down through the system and it's draining out within 4 hours. And then still, especially in dairies, the effluent from our system still have a good quality of nutrient levels in it. So you can actually, they're beneficial to irrigate crops with our effluent. And meanwhile, the worms and bacteria, as they're digesting the waste, the worms particularly are producing castings, which is worm poop. And that's actually a very nutritious soil amendment. So it's a beneficial byproduct. And throughout this entire system as well, it's using up to 95% less electricity than traditional technologies. So many people use aerators, for example, which are running constantly, whereas our systems only run intermittently. So each day, our system, the pumps in our system that you see, they operate perhaps at most 8 hours a day. And again, as I mentioned, in the upstream, we always need some sort of solid separation. These are the typical solid separators that we are using in the industries, primarily so it can be a rotary screen, it can be a vibrating parabolic screen, or it can be a diffused air flotation system. And then the difficulty, of course, as Russ mentioned earlier, in the dairy industry is that the majority of solids, in fact 90% of solids from the dairy industry, are smaller than 50 microns. And it's almost impossible to physically remove 50 microns. So that is why, after many years of experience, BioFiltro has come to adapt a hybrid of a diffused air flotation system in order to provide solid separation for our liquid waste management. Very quickly, just our global experience. We are currently operating in 6 countries. We're serving 6 industries, which are the food processors, the dairies, slaughterhouse, sanitary waste, aquaculture, and wineries. We have 140 plants operating worldwide, and collectively we've been filtered 30 billion gallons to date, and we have about 26 years of research and development. And so people commonly ask us first, can you handle the cold weather? Can you handle a lot of rain, etc.? This is one case, an example of our facility that is handling sanitary waste from an Air Force base down in Antarctica. So here, given the snow, the amount of snow and the amount of rain and wind that we are exposed to, we just have it in an unheated shed. And then typically for rain, it doesn't affect the system because you're just, you're diluting essentially the wastewater that we have to treat. And we also have a plant operating in the Atacama Desert, which is the driest desert in the world. And also in terms of scalability, we have experience in the mega processors as well. So our largest system to date is currently handling 2 million gallons per day. But coming back to the dairy experience, so our systems, we originally started with the dairy industry in New Zealand. Here's an example of a dairy out in there that's just handling 20,000 gallons per day. Effluent is reutilized for irrigation. We started in the dairy industry in about 2009, 2010. And then recently, in 2015, we got a call from the USDA and part of their Natural Resources Conservation Fund because they were very interested in California to find technology that is very promising in nitrogen removal. Because here in California, as well as in Washington State, they're obviously very concerned about groundwater contamination. So the project goal there was to remove at least 50% of total nitrogen from the dairy flush effluent, and the system has now been operating for about almost 2 years. In February, it will be 2 years, and it is averaging 70 to 90% total nitrogen removal. Its effluent is being recirculated through dairy flush lanes. They are finding that is also improving overall hoof health of the animals as well. And in terms of third-party studies, UC Davis and Cal Poly came in to do air, water, and economic feasibility studies. So to give you an example, this is a view of the system overhead. You can see the irrigation lines on the side of the system, the white and the passive vents on the side as well. And where those flags are, this is a pretty new system, so where the flags are, those are newly inoculated piles of worms and bacteria that we just introduced into the system. The reason why we have this sunshade essentially is to provide just a little bit of shade for the worms. Again, they're never present on the system surface. They're light sensitive, so they typically are found with 6 inches below the system surface. But we find sometimes in areas such as California where it's constant heat, providing them with a little bit of shade is always beneficial. This is an example of the effluent from Finale Dairy. You all know what your lagoon water looks like coming in. This is what it looks like coming out 4 hours later out of our system. You can see that there are no solids. The brown color also is due to the fact that when you're washing your water through wood shavings, as it is currently percolating down, it's carrying some of the tannins, which is just the natural dyes found in wood. This is an example of the biology present in the system. And then this UC Davis Department of Animal Science, they also came in and they did 2 third-party studies. And one was to study the effect of vermifiltration on basically greenhouse gases emission. And they were able to come to the conclusion that we were reducing it or ammonia emission by about 90.2%. And then they also wanted to study the effect of vermifiltration on microbial communities from wastewater. And so they essentially wanted to understand, since we are averaging high removal of nitrogen, where was it going? And ultimately what they found is that a lot of the bacteria present in our systems were just very potential nitrogen and denitrification bacteria. And also Pacific Gas and Electric Company, again, this is California, they stepped in and they also studied another pilot that we had at Fresno State Dairy. And that was a 7-month pilot project and study. And so over the course of 7 months, we averaged 90.6%. So after establishing ourselves in California, we began to make some noise. And so this is briefly just a permit from the Air Quality Control in San Joaquin Valley, which is Central Valley, California, essentially saying that there are no permits required for our system, air permits required for our system. So again, after making so much noise in California, we decided to start up in Royal City, Washington, at Royal Dairy with Austin. He came down to our Finale facility and he saw it, and he was interested in checking out the system here in Washington. So here, this plant is just handling 6,000 gallons per day. It's pulling straight from the anaerobic lagoons, and it was installed in October 2015. So it's been through a winter and a half as well. People are always asking us about snow. You can see here that there is no roof cover, and the system is operating even when there's snow accumulated across the surface. This is an example of the lab data collected from Royal Dairy. So you can see the values of total suspended solids, total nitrogen, and total phosphorus in the lagoon. And then you can see it 4 hours later after the beta. And then so you can see that across the board, we are averaging about 97% removal in total suspended solids, 93% removal in total nitrogen, and 91% in total phosphorus. Again, that is after a 4-hour process. So then here, after establishing ourselves over in Royal City, the Washington was very interested in bringing us and seeing if we could try it out here in Yakima Valley. And so here we came, and we're set up at DeRuyter Brothers Dairy. And then here, again, this is just a simple pilot. And so I'll leave it to Matthias to explain more about the system here.
Good afternoon, everyone. This is Matthias. I'm co-founder and CEO of BioFiltro. I was involved in the project at Royal City with Austin, and this is the second installation we have done here in Washington State. It's a pilot unit that was found mainly by the WSDA to validate the efficiency of the system to remove mainly the nitrogen of the water lagoon. This system was installed in September of this year. We have been running for 2 to 3 months. All you can see here are mobile units because the system is going to be running for 4 or 5 months maximum. And this is the structure of this pilot unit. First, you have this tank that we designed this tank to work like a DAF, dissolved air flotation, to remove most part of the small solid that this lagoon water have after a centrifuge. The water lagoon is in average have about 20,000 milligrams per liter or 20,000 ppm of total suspended solid that they are very fine. So it's very difficult to separate through a mechanical way using screen or rotary screen because the size of these solids is less than 550 microns. So the only efficient way is dissolved air flotation. And according to the influent concentration is if we need to add polymers or not to this pre-treatment. After this DAP unit, we pass the water by gravity to a sand media filter to reduce remaining suspended solids in the water. There is no energy pressure involved in this process. Everything is gravity. And after this sand media filter, we sprinkle the water through the BioFiltro that do the biological work. Here is when mainly of the dissolved contamination in the water as BOD, total nitrogens, nutrients are removed. So this is the complete treatment. Basically, it's a first solid separation removal stage, and secondly, the secondary treatment that is biological. Well, here's the first step, that is the DAF unit. As you can see here is mainly these tanks that we do in a mobile way, and the way how it works is that we mix air compression with water to a certain minimum pressure, and we inject this mix into these tanks. So the same small bubbles that we create go up, so all the solids start to accumulate in the upper part of the DAF, and we remove from them. That's how is the concept of a DAF. And the concept is pretty simple, but the main issue is how much solid we will need to remove, if we need to add polymers or not to the system to get the efficiency we need. After the DAF, we pass the water by gravity for a sand media to remove a smaller particle. This is only gravity. There is no energy, neither pressure involved in that. We do this sand media in a way that we can retroflash or we can retro-clean the filter without removing the sand and additional gravel we use inside. Here we have a small video. So, oh, sorry.
Just one.
So this, what you see there is the first solid separation stage. You see first the battery of the tank that do the work of a DAF. You see the compressor we use and the saturation tanks, the steel tanks where we mix high pressure air with water. And from there we generate the microbubble that we inject from the bottom of these tanks. So all these suspended solid floats. And after that, you saw a battery of another tank that are the sand media filters that we feed gravity from the DAF to the sand media. After that, we have these tanks that we're gonna see the second video. Treat the water from the DAF. From here, we hold the water and we pump it through the BioFiltro unit. It's here. Sprinkle. System is running completely. And everywhere from here. So this is the secondary treatment. It's the biological unit. We sprinkle the water into this tank and the water go gravity. It takes 4 hours from the moment we sprinkle until it will recollect in the bottom. And inside this tank you will have different medias from worm casting, wood shavings, gravel, meshes, pallets, an air chamber in the bottom. This is where more of the dissolved contamination in the water is breakdown. And after this, we can see the water, how it comes out. Well, this is the quality of water we get at the end. You can see it's like a golden color, but it's transparent water. This golden color is provided mainly by the wood shavings that give this a little bit of the tannins of the wood to the water. But you can see there is not suspended solid here, and you can see that is a quality of water that you can perfectly inject into a drip irrigation system with no problem. And there is neither odor, neither suspended solid inside this water. Well, those are the summary of this water analysis that we get in this pilot. As you can see, we'll start running the system at the end of September, and we get we have done 3 test labs until now. Main parameters in dairies are suspended solids, total nitrogens, total phosphorus. You can see that we achieve in general average 98% of removal in suspended solid, and always over 90% in the removal of the nutrients, that it's total nitrogen and total phosphorus. That 98% and 85 and 86%. We are gonna average at 90%. The systems start to have more performance over the time. Those are the first 2 months. But anyway, we are achieving a high efficiency level. Only we measure here the main parameters of a dairy water lagoon. And that is, we want obviously to answer any possible question you have about this system. We have been working the last 1.5 years here in Washington State, mainly within the dairy industry. We start with Royal Dairy with Austin, that I appreciate. He was the first person that believed in our system. He visited us in California. And this system has been running for more than 1 year. So we have over 1 year of records and water analysis. And this is the second unit we have installed at Jake's the Reuter Dairy, and getting very similar efficiencies. As we explained during the complete presentation here, the main challenge is always solid separation in dairies, and after a biological treatment that can work at a reasonable cost and without using too much energy and neither chemicals. This is a very friendly system because we don't neither generate the sludge. We get some byproducts from the system like warm acid that is very valuable for the ag. So it's a eco-friendly technology, and we thanks also to the WSDA to sponsor us in this second project, and hope that we can all this information we provide help to all of us. And please let us know if you have any question now or concern that we can answer now.
Okay, we're going to look over in the question department here. It looks like, okay, we're okay there. Okay, what is done with the solids?
Oh, tell them you can type in questions here.
Oh, yeah, okay, so on the side there where it says questions, you feel free to enter in if you have any questions that we can answer for you at this point. But one of the questions was, what is done with the solids that are removed at the DAF treatment? So currently, the proposal is anything that goes through a DAF can be utilized in some place in a compost facility. The thing we don't know about is when we're talking about fairly large volumes of this material, how much material can we process into compost, break it down enough to where it can be utilized on a field somewhere or in a crop somewhere and not be recognized still as polymer by the time a customer gets it. So it comes down to things like application rate and then just how much the polymer can break down in the process of temperature. So right now, our goal is to move away from the DAF system. We think long term that polymer is not the right answer, but it is absolutely the most effective way currently to remove total suspended solids down to a level that the biofilter can use them. Let's see what this says here. Okay, the question is, of the 12,533 total suspended solids in the lagoon, is that what's left after separation by the centrifuge and press? The answer is yes. That's prior to the BioFiltro.
Yes, in general, all these dairies, you find before any treatment, you have between 2-3% of suspended solids. After a parabolic screen or centrifuge, you will reduce until level of between 10 to 20,000 milligrams per liter of suspended solid. But to enter to any kind of biological treatment, you need to reduce this suspended solid to levels of 1,000, 2,000 maximum. And that's why we need to get some 90% reduction of suspended solid before enter to the biological treatment. So yeah, the answer is yes. And according to that is what we need to do for extra solid separation before enter to the biological treatment.
So kind of just a general comment about the purpose of a biofiltro. Its primary job is to remove nitrogen and small levels of total suspended solids. So one of the things that it does great is the worms help remove the suspended solids. The bacteria that the worms produce help reduce the nitrogen and put it into a format that can be utilized as castings. So, but in the process of doing that, the water has to be, the total suspended solids has to be down to a point where the worms basically aren't overwhelmed with solids, because the next option would be to produce a extra large system, but the economics aren't justifiable. If you, for example, if you were to use a 1 acre system to process so many solids, if you were to increase the number of solids coming in by 10, you would need to increase the capital cost of that system by some magnitude in order to justify putting a high level of solids in. And the economics are just not feasible, we don't think, for that kind of application. So even in the case of a DAP, it's less expensive than scaling up BioFiltro to accommodate. But keep in mind, this whole system's job is to reduce nitrogen primarily, not to reduce suspended solids. It does that also. But that's the goal is primarily is a nitrogen cleanup system. Let's see, what's the percentage solids of the liquid before sprinkled into the worm bed? So there's been approximately a 98% reduction. So if you're talking about something like 20,000 solids coming into the DAF, you're talking about 2,000 going into the BioFiltro. It gives you kind of an idea. And it's been, most of the solids that are suspended have been resolved by the DAF, not the BioFiltro, because that's not its job. We're trying to get it down to the point where the...
Anyway, from the BioFiltro, you enter with between 1,000 to 2,000, but the effluent of the BioFiltro is going to be less than 100. So at the end of the day, that's why we are removing between 99 to 100% of the suspended solid that we take from the pond or lagoons.
Okay, I got another question here. Can't get on how to click on there. Okay. Operational cost per gallon for the BioFiltro, excluding DAF and primary separation. We're doing some math here to give you a specific answer. It depends, I guess, on the size of the system going in, but we're doing a little bit of, but we're burning up the calculator here while we're doing some math.
We'll come back to that.
As far as manure being corrosive to the cement, what is the lifespan of the cement bunker holding the worms? How long is
our longest operating system has been operating for 26 years. Our oldest dairy has been operating for 6 years. We have plants that have been operating, again, for the longest operating system has been doing 26 years, and it has yet to be changed. The only thing that you haven't changed, that's a good question that we haven't answered, what is the maintenance, the big maintenance items of these plants? What you do have to do is, again, over time, as the worms are pooping, they're pushing their poop or their castings to the system surface. And approximately for dairies, once every 18 months approximately, you need to come in and just remove the top 6 to 10 inches of the system. And what you're actually removing are the castings. So once you remove that layer of castings, you just put in fresh wood shavings. So now, Matthias, we're going to go back to the previous question of operational cost per gallon for the BioFiltro system.
Yeah, so not including the DAF, the cost between CapEx and OpEx is going to be between half to 1 cent of dollar per gallon treated. This is going to be dependent about the construction cost that is going to be involved if the land is flat or things like that. But to keep an idea, is between half to maximum 1 cent per gallon treated.
Yeah.
Yes, so the BioFiltro also reduced fecal coliform in a 99%. We decrease one logarithmic scale of concentration of fecal coliform, but that doesn't mean that we arrive to standard to discharge to a river or things like that. So in general, if we want to discharge to a stream or to irrigate some special crops, we need to disinfect the water after that. And we have done disinfection with a couple of different options between chlorination, ozone, UV lights. We have used all of them depending on local regulation. In some places, chlorination is not allowed, and we have been used UV lights and ozone in those cases. How do you look at it? Okay.
Does anyone else have any more questions? No. Yes. So the question is, in general, are the farmers operating these systems? So we do ask, there are basic daily maintenance tasks that we do ask of the farmer. And what is that? You need to go out and visually inspect the pumps. For example, are the pumps operating? Are they under stress? We always have contingency pumps, aka there'll be 2 pumps stationed at each station in case one breaks down. Common issues that can occur with the BioFiltro system is perhaps the irrigation sprinkler head gets clogged. You're able to walk on these systems. It's not like a pool or it's flooded or anything, so you can walk across the system surface. And what you would do is just jump into the system, take off an irrigation head, and pop it off. So the answer is yes, the farmers are operating the day-to-day. There are very few moving parts. The parts that are moving in terms of the BioFiltro in of itself is a pump and an irrigation system. When we have, of course, like the DAFs, what you do need to have the farmer do is just essentially remove, kind of like scrape off the solids. But the important part and where our BioFiltro has its founding is that the idea of our entire system is to be operator friendly. It's all open. You can see all the moving parts. All the parts are made here in the US. They're provided locally. So in that sense, if you need a replacement, you recognize it, etc. And so it's very basic operations.
Yeah, and in general, about these 140 plants we have installed worldwide, all of them are in rural areas. So this system applies very well for places where it's very difficult to find skilled people, or sometimes when you depend about supplier for specific components and equipment. This is one of the main benefits of this system. It is simple to operate. So we have been seeing that Austin, for example, from Royal Dairy, he understands very well how this works, and he understands that the same people that work in the dairy, they can do their daily minimal operation that is required. So this is a system that can be handled by farmers, and it's pretty simple, and that's one of the main benefits and why we have been installed so much unit in rural areas where skilled, sometimes chemical people or very skilled people is difficult to find.
Our idea, of course, again, is that we want to make it as operator friendly as possible so that the dairy farmers can focus on their prime business. So what about the footprint? As someone's asking, what about the footprint? How much space is needed to treat 20,000 gallons per day?
To do it, always going to be depend about which is the quality of water of each. We can say that each dairy is different, but in average, I will say that for this quantity, you will need, for 200,000 gallons a day, you need about 2 acres. So in this case, you will need 0.2 acres. It's about 4,000 square feet. 40,000 square, 4,000 square feet. So, but in general, for each 100,000 gallons a day, we need like 1 acre. This is like a main parameter for dairies.
Great.
Okay, so a couple of things just to consider. So when BioFiltro we first kind of found each other, we were struggling trying to find an answer of what could we do with dairy water that would give us a tool that we can use. I'm convinced that the BioFiltro has potential as a tool. I think there was a Brown and Caldwell engineer I spoke to in California, and I asked him specifically what he thought about the BioFiltro, and he said, look, there is nothing that solves every problem, but he said for what the BioFiltro is meant to do, it's one of the best tools that I've seen at the lowest cost. And that specifically is to remove nitrogen and to remove a moderate level of total suspended solids. In the application for like wineries, anybody who's got fruit processing and things like that, this thing is a snap. It's a very easy fit for a lot of these guys who are putting in new wineries. We've been talking to them because their solids content is so much lower. And BOD is one of their big concerns, and this thing reduces BOD by 90% plus. The dairy industry has these fine solids that are a challenge. So I can't really get Austin on this call like I had hoped to, but one of the things that he's considering is remodeling or reconsidering the way he's doing his manure management. Now, I don't want to put words in his mouth. I guess I could anyways. But he's trying to figure out, if I didn't flush and I changed my methodology for collection, could I justify collecting manure in some other way and the offset cost of water management, and potentially on the solid separation on the front end, would I have enough, would I be able to justify handling the solids in a different way? So there's all kinds of opportunities out there for exploration in what can we do on the front end. And I don't think necessarily, at least in my heart of hearts, I don't know that a polymer-based solution is the answer, but it may be a portion of the answer. Another question? Okay.
Does anyone else have any other questions before we wrap up?
Looks like that's about it. Okay, well, sorry about the change of venue over the kind of short notice. The weather has been, exciting at the least. I know that all the dairymen today and tomorrow and this weekend are going to be thinking about the weather as the temperature drops. I was thinking about pipes and cows and ice, and it's going to be tough for you guys. So We appreciate the fact that you made the time to get on this call. We're thankful to the Department of Ag for helping us in this project. I'm super thankful for Jake and Jenny DeRuiter of taking a risk to do the pilot with us, and Austin as well. I appreciate you all making the time today, and we're going to, again, have this presentation online. It'll remain there for a while, and it'll be downloadable at a later date, and we'll also send a copy of this presentation to everyone who is on the call today. So once again, thank you so much to everyone, and if I don't talk to you before then, Merry Christmas to everyone.
Thank you.
Thank you.